Hello, so today I'm going to be solving logarithmic equations, and I know this is a bit of a random jump from my last video, but I thought this was a good topic to cover, and hopefully next week I will do a video over exponential equations. So first off, I'm just going to start off by writing the logarithmic equation and the exponential equation, and why I'm doing this is because, as you'll see in a second, these equations look pretty similar. And that is because they're inverses of each other. So when you solve a logarithmic equation, you have to convert it to its inverse, the exponential form, to get your answer. So you'll see this in a second with my first example. So as you can see, this is in logarithmic form. And to solve this, you have to convert it to exponential form. So this 5 will come right here. This x will become this exponent. And the argument will swing over to the other side of the equal sign. And this is your equation. And this is an exponential equation. And so now we just have to solve for x. So x to what? 5 to what power gives you 125? And that is 3. So your answer is just x equals 3. And you're done. So that's pretty easy. Now we'll do another problem. A little bit different. So, I'm just going to write it down real quick. So now we have 2 logs on each side of the equal sign. And when this happens, if they have the same base, which is 4, this 4 is the base, we can just drop the log and we just set the arguments equal to each other. So this will be x plus 6 is equal to 3x minus 7. Now we just solve for x, so I'll add this 7 over and subtract this x over, and we'll have 13 is equal to 2x, divide by 2, x is equal to 6.5 or 13 over 2. And so now, in this case, we're done, but you always have to check your answer. You have to plug this number back in to the x's to make sure that this argument is positive. And if it is negative, it's no solution, and it's an extraneous solution. I hope I'm saying that right. But yes, so it will be no solution. And in this case, it is positive, so you don't have to worry about that. But just always make sure to plug it in to make sure that it is positive. Now on to our next question. So let me just write it down real quick. So now you may be thinking, oh, there's 2 logs on each side of the equal sign, so I can just drop the log, set the arguments equal to each other, but that is not the case. So you have this 2 right here, so you're going to have to subtract this log over to the other side. So the logs will be on the same side. And now we're going to incorporate something called the quotient rule. So the quotient rule is a rule that states that if you have 2 logs that are being subtracted by each other, you can divide the argument. So what that will look like is this. So now you have this. And now it's time to convert it to exponential form to get your answer. So as you know, if you have a log right here and it has no number for its base, it's an implied 10. So this 10 will come down, this 2 will become this exponent, this argument will swing over to the other side. And so this will just be 100. So 100 is equal to 5x minus 1 over x minus 2. Now to get this numerator by itself, we just multiply each side by x minus 2. And then I'm going to come up here. We are left with 100 x minus 2 is equal to 5x minus 1. And then we'll distribute this to get 200x minus 200. Oh, I meant 100x. That is my bad. So 100x minus 200 is equal to 5x minus 1. And now we just solve for x. So I'll add this over, subtract this over, and then you're left with 95x is equal to 199. Divide by 95, x is equal to 199 over 95. And like I said, you have to check to make sure that when you plug this in, it is positive. So, in this case again, you don't even have to do the math for this one. You really just know it's going to be positive because that's a pretty big number. And yes, so now on to the next problem. So that was the quotient rule. Now we're going to do something called the product rule. So you will see what that is in just a second. Product rule states that if you have two logs that are being added together, you multiply the argument. So this is what that will look like. And this side. And so now I'll just distribute this 10. And so now you have two logs that are set equal to each other. And like I said, when you have this, you can just drop the log and set the arguments equal to each other. So and now this becomes a pretty simple algebraic problem. So you'll have 0 is equal to x squared minus 7x plus 10, and now you just and then you solve for x, so you'll have x equals 5, x equals 2, and now we're not done. We have to plug these back in. So first we'll do 5, so we can see if we plug in 5 here, 5 minus 2 is 3, and then if we plug in 5 here, I'm not going to do it, but you do get a positive number. But now when we plug 2 into here, we get 0, and so that's not going to work. And in this case, we will have to cross this out because it is an extraneous solution. Again, I hope I'm saying that right. I'm not 100% sure, but I know you have to cross it out. So it's just x equals 5, and that is your answer for this problem. So now this is going to be our last problem for this video, and I wouldn't say it's super hard. Just the only thing that's hard about it is it just incorporates a bunch of rules, and so that's the only thing that I would say is difficult about this problem. So the first thing I'm going to do is bring this over and make it an exponent. So if you know like the condensing and expanding rules, you would know that this is an exponent. So I'm just going to rewrite this side of the equation and make that 1/2 an exponent. And now we're using the product rule. So when you have two logs being added by each other, you can multiply the argument. So I'm going to rewrite this again. So now we have this new rewritten equation, and now I'm going to multiply all this together, and I'm going to rewrite this as a square root, because if you set something to the 1/2 power, it's the same thing as square rooting it. So this is what that will look like. And now I'm just going to subtract this over. So I will have And now we are incorporating another rule, and this is the quotient rule like we did earlier. So I'm just going to rewrite this again. I know I'm rewriting this kind of a lot. I'm watching this while I'm editing, and that should say x, not ln x, in the denominator. And so I'm just going to write this on the other side because I think it makes it easier, at least to me, in my brain. Okay, so now we know that this is a natural log, so ln can also be written as log base e. So now it's time to convert this to exponential form. So once we convert this, I'm going to move up here. So once we convert this, you will get e 0 to the 0 and 4x plus 5 over x. So now what we do is we can take a look at this. So anything to the 0 power is going to be 1. So we'll rewrite this again and multiply each side by x. So this numerator is by itself. So now how do we get rid of this square root? Well, we square both sides. And that is how you get rid of the square root. So now we have x squared is equal to 4x plus 5. And then we just subtract both of these over, and it becomes a pretty simple algebra problem. So now all we have to do is factor them, and we are done. So this is x minus 5, x plus 1 is equal to 0. And now solve for x. X is equal to 5. X is equal to negative 1. And we know that the negative 1 is probably not going to work. And as you can see, when you plug it in, you get a negative argument. So this becomes an extraneous solution. And you're left with 5. And once you look back at the original equation, you can see that once you plug in 5, you're going to get a positive argument. So this is your answer. So that is it for today's video. I hope you enjoyed this. If you need clarification for anything that I said in my video, feel free to leave a comment below, and I will try my best to explain something that I may have not explained well in the video. And so I hope you have a good day, and goodbye.